Hey guys, in this video we're going to talk about Chapter 14, Section 2, Computing Partial Derivatives Algebraically. So since we're going to be taking derivatives, if you need a review on taking derivatives, product rule, quotient rule, chain rule, especially for some of you guys that didn't take me for Calc 1, you guys can check out my Calc 1 playlist on my YouTube channel, and you know, you can review these rules if you're a little bit rusty with them, but hopefully a lot of this will be pretty intuitive, just because we've done this same kind of process before in Calc 1. We're just moving up to the third dimension. So let's just get right into it. We have a function of two variables, two inputs. We have x squared over y plus 1, and what we're trying to do is we're trying to find the partial derivative in the x direction at x equals 3, y equals 2, okay? So the key thing to remember about this is that we are going to fix our y value when we're looking in the x direction, all right? So what that means is we're just plugging in our y value here. That's what it means to be fixed. We have that constant y value 2. We're going to plug it into our function. So we have f of x fixing 2 as y. We have x squared over 2 plus 1, and so that's just x squared over 3, which is just a third x squared. So now we can just take the derivative like we normally would using the power rule, so using the shortcut. So we multiply 2 times a third to get 2/3 in the front, x, and then 2 minus 1 is going to give us a 1 on the exponent. Okay, so this is f. This is the partial derivative with respect to x. We just differentiated x. We let y be a constant. And what I want to do is I want to actually figure out the slope. Like, this gave me a slope function, but I actually want to figure out what the slope is at this point right here. So just like in Calc 1, we're going to plug in our number for x, and we get that the partial derivative with respect to x is 2/3 times 3, which is just 2. So that is our answer here. Okay, so let's take a look at this problem. Now I want to introduce some new notation here. This guy right here just means the derivative, the partial derivative with respect to y, and this guy right here means the partial derivative with respect to x. So it's just some notation that you might see. Alright, so let's go ahead and differentiate this. Now remember, anytime we see a y, we're going to treat it like a number. So y to the 7th is just a constant, right? If we're looking at first taking the partial derivative with respect to x. So how do we do it? Well, again, everything that has a y, we treat like it's a constant number, and we know that the derivative of constant is 0. So let's go ahead and figure out what the derivative of this guy is with respect to x, the partial derivative. Okay, so if I take the derivative of 3x to the 5th, y to the 7th, this is the product rule, right? So I keep the first, 3x to the 5th, times the derivative of the second. Now the second is y to the 7th. Now what's the derivative of y to the 7th? Since we are looking at the partial derivative with respect to x, the derivative of anything with y in it is 0, okay? Plus, now you keep the second, which is y to the 7th, times the derivative of the first. What's the derivative of 3x to the 5th? That's 15x to the 4th. Okay, so that's our first one. Let's go ahead and look at this one. So I'm going to just factor out this negative. And I have 32x to the 4th, y to the 3rd. Okay, well actually, let's just get into it. So first of all, keep the first, negative 32x to the 4th. So negative 32x to the 4th times the derivative of the second. What's the derivative of y to the 3rd? Well, it's 0, right? Anything with a y we're considering to be constant, so the derivative is 0. Plus, now you keep the second, y to the 3rd, times the derivative of the first. Well, what's the derivative of negative 32x to the 4th? Well, let's see. 32 times 4, we get negative 128 x to the 3rd. Okay, so keep the first times the second, derivative of the second, plus keep the second times the derivative of the first. Okay, and finally we have this guy, all right? So again, product rule plus keep the first, 5 times x, times the derivative of the second, derivative of y is just 0, plus keep the second, y, times the derivative of the first. Derivative of 5x is just 5. And then we can simplify, we can clear out these 0 terms, 0, 0, and I get that my partial derivative with respect to x is going to be, let's see, we have 15x to the 4th, y to the 7th, minus 128 x to the 3rd, y to the 3rd, plus 5y. And that is my partial derivative in the x direction. Alright, now let's find the partial derivative in the y direction. Now, we're gonna take the derivative of y like we normally would, any kind of y terms. But anytime we see an x term, we're going to treat that like it's a constant. And so the derivative of any x term is going to be 0. Alright, so let's do this. So we have f of y equals, alright, so keep the first. We have 3x to the 5th times the derivative of the second. Derivative of y to the 7th is 7y to the 6th. Right, because I'm treating the x as it's a constant now, and I'm differentiating the y stuff like usual. Alright, so keep the first times the derivative of the second, plus, now you keep the second, y to the 7th, times the derivative of the first, which is 0, right? Derivative of 3x to the 5th is 0 because anything with an x in it, we're treating like it's a constant, okay? Alright, now let's do the second term in purple. We have keep the first, negative 32x to the 4th, times the derivative of the second, which is 3y squared, times, or sorry, plus keep the second, y to the 3rd, times the derivative of the first. Well, the derivative of anything with x in it is 0, right? Because we're treating it like it's a constant. And finally, the green. So we have 5x is our first, so plus keep the first, times the derivative of y, which is just 1, plus keep y times the derivative of 5x, which is 0. Okay, so now we can clear out our 0 terms and clean it up a little bit. So the partial derivative with respect to y is going to be, let's see, we have 21x to the 5th, right, 3 times 7, y to the 6th, minus, this goes to 96x to the 4th, y squared, and finally plus 5x. So this is our partial derivative with respect to y of this function. Okay, let's do another example. So this is some more notation. So this just means partial derivative with respect to x, and this means partial derivative with respect to y. Okay, so just other notation here. Okay, so I'm going to do my x direction first. Remember, we're keeping y as a constant here. So let's start with this first chunk in red. Keep the first, 5x squared, times the derivative of the second. What's the derivative of y to the 3rd? It's going to be 0 because we are working in the x direction, so we're keeping y as a constant. Anything with y as a constant. Okay, keep the first times the derivative of the second, plus now keep the second time. Notice I didn't take the derivative, so I just leave it as y to the 3rd, right? So keep the second times the derivative of the first. Well, the derivative of 5x squared is just 10x. Okay, now let's do this green. So keep the first, 8x, times the derivative of the second. Well, derivative of y squared is just 0. Plus keep the second, y squared, times the derivative of 8x, which is 8. Okay, finally this guy. Now this guy doesn't have a y in it, so we just differentiate as usual. So using the power rule, this is negative 6x when we take the derivative. Alright, clear out my zeros, clean it up. So we have partial derivative with respect to x is 10x y to the third plus 8y squared minus 6x. And that is our answer there. Okay, now let's do with respect to y. So now everything with x is a constant, and hence the derivative is 0 with respect to x. Okay, so doing the red, we keep the first times the derivative of the second. Well, the derivative of y cubed is 3y squared. Remember, it's not constant anymore. The constant stuff is the x. Alright, so keep the first times the derivative of the second, plus keep the second times the derivative of 5x squared. Well, anything with an x squared is 0 when we're looking in the y direction. Okay, so that's red. Maybe I should have done that in red. Oh well. Okay. Let's go ahead and do the next one then in green. So plus keep the first 8x times the derivative of the second, which is 2y, plus keep the second y squared times the derivative of 8x. Well, the derivative of 8x is 0. And finally, the yellow, the derivative of anything with x is just 0, so that's just 0. We don't even have to write it. Okay, clear out the zeros and simplify. So the partial derivative with respect to y is going to be 15x squared y squared plus 16y squared. I'm sorry, this actually, I think I made a mistake here. This is going to be 16xy because, let's see, what did I do? Oh, right, okay. Yeah, so I actually made that a y when I should have kept it as an x. So that is our answer right here. Okay. Let's try this one. So another notation. So the little z sub x, again, is just a little directional derivative in the x direction. So partial derivative with respect to x. Okay, so this is chain rule. You guys remember the chain rule? Chain rule says we're going to first take the derivative of the outer function multiplied by the derivative of the inner function. Okay? So again, you know, if you're rusty on chain rule, go ahead and review those Calc 1 videos. But the idea here is that we are going to bring this exponent 7 to the front, leave everything as it is on the inside, and subtract 1. And then, so we took the derivative of the outer function, times the derivative of the inner function, which is this guy. So since I'm doing this with respect to x, this is going to be 2x plus 1 minus 0, right? Anything with y goes to 0 because we treat y as if it's a constant. So our answer here is just 7x squared plus x minus y to the 6th times 2x plus 1. And it didn't ask for the partial derivative with respect to y, but we could do it the same way. The only difference is that when we would multiply by the thing on the inside, we would just be multiplying by -1 because this clears to 0 when we take the derivative, so does this. Derivative of negative y is -1. So, yep, that is it. Let's try another one. So, remember from Calc 1, the derivative of e to the x is just e to the x. So here, we're gonna first find the partial derivative with respect to x, and so we have to use the product rule and the chain rule, okay, because we have a product of functions and we have an outer function e to the x and an inner function 3x. Okay, so let's go ahead and not erase everything. Let's go ahead and do this. So product rule, so we keep the first y squared times the derivative of the second. Well, the derivative of e to the 3x is just going to be derivative of the outer function, which is e to the 3x, times the derivative of the inner function. So the derivative of 3x is 3, okay? And that's it. And I could leave it like that. I could write it a little prettier, but I'm just going to leave it like that. Now let's look at the partial derivative with respect to y. So again, product rule, keep the first. Ooh, wait, I don't think I finished the product rule for the x. Okay, sorry. So keep the first times the derivative of the second plus keep the second y squared times the derivative. Oh, sorry. Oh my gosh, what is going on? Keep the second e to the 3x times the derivative of y squared, which is just 0. So that goes to 0, and this is my answer right here. Okay, because the rest of it goes to 0. Alright, sorry about that. I lost my train of thought for a second. Now let's take the derivative in the y direction. So again, product rule. Keep the first times the derivative of the second. Well, the derivative of e to the 3x, since we have an x involved, I mean, what we're going to end up getting is e to the 3x. And when we differentiate with respect to x, we just get 0, right? Because x is held constant. So this is essentially just y squared times 0. Alright, so keep the first times the derivative of the second plus keep the second e to the 3x times the derivative of y squared, which is 2y. Okay, so my answer here for the partial derivative with respect to y is just 2y e to the 3x. And that is my answer there. Okay, let's try this one. So first we want to find the partial with respect to x. So we have chain rule again. So our outer function, we have to do bring the exponent to the front. So we have 5, 3xy plus 2x, and we're going to subtract 1 from the exponent. Then we're going to multiply by the derivative of the inner function, which is all of this stuff. So the derivative of the inner function, well, the derivative of 3xy, so we keep the first, 3x, times the derivative of y, which is 0, plus keep the second, which is y, times the derivative of 3x, which is just 3. Okay? Plus, and then the derivative of 2x is simply 2. Okay? So then we can simplify this out a little bit. So we have the partial derivative with respect to x is 5 times 3xy plus 2x to the 4th times 3y plus 2. Okay, now let's do partial with respect to y. Okay, so again, this stays the same, right? The outer function, we have 5 times 3xy plus 2x to the 4th. This time, when we multiply by the derivative of the inner function, we're treating the x's like constants. So for this part right here, we keep the first, 3x, times the derivative of the second. Well, the derivative of y is just 1. Plus, now you keep the second times the derivative of 3x. Well, the derivative of 3x is just 0. Okay? Plus, the derivative of 2x is 0, because again, we're treating everything with x as if it's a constant. And so our answer here is just going to be 5 times 3xy plus 2x to the 4th times 3x. Okay. All right, let's try this bad boy. This one looks kind of interesting. This one might be fun. So we have a product, and I see some chain rule also going on. So let's find the partial with respect to x first. So we keep the first, e to the x plus 3y, times the derivative of the second. Well, the derivative of sine of xy, derivative of sine is cosine. Okay, so we're using chain rule here. So we have the derivative of sine of xy is the cosine of xy times the derivative of xy. Well, the derivative of xy, keep the first, times the derivative of the second, which is 0, right? Derivative of y is 0. Plus, now you keep the second, times the derivative of x, which is 1. Okay, so we just used the chain rule here, okay? So, okay, let's review what we just did. So we're using the product rule. We kept the first, times the derivative of the second. This is the second right here. Okay, plus keep the second, sine of xy, times the derivative of the first. Well, the derivative of e to the x plus 3y is just e to the x plus 3y times the derivative of x plus 3y. Derivative of x is 1. The derivative of 3y is 0, right? Because y is a constant. So this is just, sorry, not times 0, times 1. So we have partial derivative with respect to x is going to be e to the x plus 3y, and I'll clean all of this up a little bit. Then we have cosine xy plus y plus sine of xy times e to the x plus 3y. And let me check my work, make sure that I didn't do any kind of computational error here. Let's see. Yeah, okay, keep the first times derivative of the second. Oh, I'm sorry, this should have been in parentheses. This should have been times y. There we go. Okay, so that should be it. Okay, so that is our partial with respect to x. And let's go ahead and do our partial with respect to y. So keep the first, e to the x plus 3y, times the derivative of sine of xy. So derivative of sine of xy is cosine of xy times the derivative of the inside. So derivative of xy is keep the first times the derivative of the second, which is 1, plus keep the second, y, times the derivative of the first, which is 0. Remember, x is a constant when we're looking at the partial derivative with respect to y. Alright, so keep the first times the derivative of the second, plus keep the second, sine of xy, times the derivative of e to the x plus 3y. Well, that's going to be e to the x plus 3y times derivative of x is 0, derivative of 3y is 3. So this is our answer. We have partial derivative with respect to y is e to the x plus 3y times x cosine xy plus 3 sine of xy e to the x plus 3y. Okay, so we just found the partial derivative with respect to x and the partial derivative with respect to y. Okay, let's try one more. So we want to find the partial derivative with respect to x if our function of two variables is x times ln of y times cosine of x. So remember, the derivative of ln of x was 1 over x. So it looks like we're going to have to use that fact along with the chain rule and the product rule. Okay, so let's go ahead and get started doing it then. So keep the first, which is x, times the derivative of the second. Well, the derivative of ln of something is 1 over that something times the derivative of that something. So the derivative of y cosine x is going to be keep the first, y, times the derivative of the second, which is negative sine x, plus keep the second, cosine x, times the derivative of the first. Derivative of y is 0 because we're working in the x direction here. Okay, so let's just so we're doing the product rule between x times ln of y cosine x. So the first factor is x, the second one is ln y cosine x. So keep the first times the derivative of the second. This whole thing is the derivative of ln y cosine x. Okay, so keep the first times the derivative of the second, plus, now you keep the second, ln of y cosine x, times the derivative of the first. Well, the derivative of x is just 1. And then we can clean it up a little bit. So, let's do that. This goes to 0. Let's see. So, partial derivative is going to be x over y cosine x And then we're going to multiply it by negative y sine x. And then we're going to add to it ln of y cosine x. Okay. So I guess the y's can cancel. That would clean it up a little bit. And we get negative x sine x on top over cosine x on bottom, which, by the way, is tan x. Just a little Easter egg there. Not really important, I guess, but anyway. And we have this. Alright, so that's it. Now, if we wanted to do the partial derivative with respect to y, again, we would just treat all of our x terms as if they were constants. Alright guys, thanks for watching this video. I will see you guys in the next one.